Good morning. I'm impressed. 8:30 after the party last night. Who went to the party? It's a hard time slot. I didn't expect as many people to be here, so I'm impressed in y'all. This is my 10th year in a row being at CodeMash. But because I had this slot, I didn't go party last night, and it's the best I've ever felt Friday morning since in these 10 years. So yeah, I'm Brian Genisio. I'm going to talk about GraphQL today. And I'm not going to talk about how REST is dead. That was really just sensationalism. I have had people suggest that it's irresponsible of me to suggest it in my thing that REST is dead, but I thought I was pretty clear that I was just kidding. I do think REST has some limitations, but I also think GraphQL has some limitations. So I'll be talking about all those things. Just put it out there in the open, right? So I work for a company called Khan Academy, and it's our mission to provide a free world-class education for anyone everywhere. This is a nonprofit. Nobody ever pays other than if you want to donate, but no one ever pays to use this system. We're also hiring. This is a place that allows remote work and is one of the most empathetic, skillful, and talented group of people I've ever worked with. And I'm humbled every day to work with them. It's just an amazing place to work. So, talk to me if you're looking for something like this. Yeah, let's talk about GraphQL. First of all, what is it? It's just this is the simple definition that Facebook gives it, because it's produced by Facebook. It's in many ways part of the React ecosystem, but they say it's an open specification for a flexible API layer. That's really kind of nebulous. It doesn't mean a whole lot. Here's a quick example of what a query looks like. This is a thing that the client asks for the data. Instead of in the REST world where you make a request for a resource and the server gathers all the data that it thinks you needs and sends it down. In this case, the client says, this is the data I want, and it posts this document and it gets the data back. And so this is just an example of a query. We're going to see several different implementations of GraphQL today, but this one happens to be a Star Wars movies database. And so this is just all the people in the world. We'll see this execute later, but this is just an example of what this query language looks like. It's server agnostic. Facebook came up with a reference implementation written in Node JavaScript, but really there's a library for GraphQL in pretty much every major language you can think of: Java, .NET, Go, Python. It's all there. And it doesn't really matter what data store you have on the back end, because this is an interface layer. That's all it is. It gives you a way to query the data, and then you have to implement how to get the data. So it can be a database. It can be another REST interface. It can be shared pipes. It doesn't much matter where the data comes from. It could be JSON files. Just doesn't matter. And you can probably figure out already, it doesn't matter what operating system you're running on. Like it may be made by Facebook, but it's just a thing that exists in an ecosystem. And there's lots of libraries that implement this for you. It's also transport agnostic. It's very common to do GraphQL over HTTP. You'll see that a lot. In fact, all the examples that I'm going to show have it going over HTTP, but it's not specified in GraphQL that it goes over HTTP. You could do GraphQL over the command line. We'll see a quick example of that today. You want to just go over plain TCP or any remote procedure call style thing? Go ahead. It doesn't matter, because all you're really doing is getting a document to a transform somehow. That's what GraphQL is in a nutshell. And so before we get into examples and talk about client and server and all this stuff, I just want to talk about the problems that it solves. It's a typed API. So this allows things like introspection. In your development tools, you can immediately get auto-generated documentation. You can get IntelliSense, things like that as you're writing your queries. All sorts of tooling is able to now sit on top of it and make really informed assumptions about your data because it's all typed. Linting, for example, like I'll show an example, but like one of the greatest things that we do at Khan Academy when it comes to GraphQL is we get to lint our queries, our client-side queries, against the schema on the back end. And so if anything were to change, if anybody were to make a small change on the back end and think that they've only affected one place over here, our linter would say, over here, this query doesn't match your schema anymore, and you can fail to build or whatever. So the typed API gives you a lot. The other thing that's really kind of nice about it is you fetch only what you need, and nothing more, nothing less. You define the data that you want, and so this makes it so you're not like overfetching from the database. It makes it so you're not sending too much data down the wire. There's lots of benefits when the client says, "Hey, I only need the ID and the name for this giant entity. Only send me the ID and the name, please." So the idea behind it all is that you have a graph of data. This can be a relational database, a graph database, document database. It doesn't much matter. But if you think about your data in terms of a graph, which much data can be, but what you're doing is you're querying into it and turning it into a tree of data, JSON data, essentially, from that graph. So again, we've got, in this case, we're gonna just conceptually query on characters and the movies that they're in. And so then we get the characters and the movies that they're in. And the tree can be really any depth of as far as you go. Like here's an example of, this is kind of the query for what you saw above. You're going to query the people, you're going to get the name, you're going to get the films and such. And in this example, they've got like this films connection films. That's all defined by the API implementer. That's not defined by GraphQL. So you'll see examples where it's a little bit more nested than other cases, and that just comes down to how the interface is implemented. You get to decide what the graph looks like. You get to decide what the nodes are called and work from there. You get to decide how paging works, all that stuff. The other thing that I really like about this is that you can fetch multiple trees at a time. So if anybody's ever written like a single page application in JavaScript where it comes up and with REST it needs to make 12 queries to the REST interface because it needs resources for all different things on the UI. So this allows you to make in one query get all the data. And as you'll see a little bit later, it also allows you to then say, okay, I've got all these different queries in different parts of my application. They'll be separated, and there will be tooling that glues it together and asks for one thing, even though my smaller components are asking for little bits. It also allows documentation built in to it. And so even if you don't write documentation strings along with your API as you implement it, you at least get the type-based documentation, which gets emitted from your API. And along with documentation then comes deprecation. So no longer are the days where you have to have version 1, version 2, version 3 of your REST API. You can now start deprecating fields and add new fields to replace them. And as long as the developers are paying attention or have ways to log the fact that you've deprecated it, you can make a request and you can get extra metadata that says, hey, this has been deprecated. You should know about it. And so, like, if you were going to compare this to REST, and again, I don't think REST is dead. I think REST has its place, and it does and it has, especially with hypermedia extensions to REST, it can do a lot of the things we talked about. But REST out of the box, they have resources just like GraphQL has the sense of resources, and they both can return JSON. REST has multiple endpoints where GraphQL tends to have one endpoint, but then you get all these extra things that come along with GraphQL out of the box, which is kind of nice and really nice for application development especially. These are things that as a developer I care about, and as a team lead I care about, because it helps us communicate better, and it helps our tooling make sure that we make fewer mistakes. And so we at Khan Academy, we were switching all of our REST-ish APIs. I call it REST-ish because they're really not like conforming to any REST standard I've ever seen. We're moving them all over to GraphQL, and all new things are in GraphQL. So it's a migration that we're doing slowly over time, and there are benefits to doing so that we'll talk about on the client as we go forward. So yeah, let's talk about some query examples. Let's talk about some client-side query examples on how you do this. And before we do that, I want to talk about this this tool called Graph.cool, and this is GraphQL. Okay, it's a Rack component that you can plug in that talks to a GraphQL backend. And so what you're going to see in all these implementations, I have an implementation of GraphQL being hosted up by the same endpoint as the GraphQL API. And what's nice about this is, because of introspection, I can get IntelliSense and figure out what I want here, and I can execute, and I can build my queries in this tool, and then copy my query over to my client, and my client can get that data. And then because it's, this particular interface doesn't have any specific documentation, but it still gets all the type information. So if I wanted to find out things like the planets in this database, I can find out that, here's a planet right here. Diameter, rotation period, orbital period, gravity, all that stuff is in this database. The thing that's not in this database is the new movies. So don't be like, actually, Luke Skywalker was in Last Jedi. I didn't make the database. So yeah, that's GraphQL. We're going to see all of our queries done in GraphQL. So let's start simple. Let's start just with what a simple query looks like. And this is it. I'm going to move over to a different. So here we actually have an interface, a GraphQL wrapper around the REST interface for CodeMash. So here are the sessions that we have today. And so here's an example of a very simple query. And it starts with the word query because you can also have mutations. In GraphQL, we separate the concept of queries and mutations as clearly different types of work. So we're doing a query on sessions, and I want to get the title. Okay, really quite simple, and you'll see here are all the CodeMash session titles. And then you can take that and you can dig deeper. And so let's do that. So now I'm going to say I want the title and abstract, I want the rooms, I want the speaker's first name and last name, and I can call that and I get that. There's my title, my abstract, the rooms, and the speaker array as well. And apparently rooms is also an array, so I made from the API, so I made that happen as well. So yeah, so that you get the idea. You ask for the data you want, and you get the data you asked for. There's also, this is a graph that you're peeking into, so you'll see references to if you make queries this way, you will see references to the same things. So here I'm saying, give me all the sessions, and give me all the rooms, and for those rooms, give me all the sessions that are in that room. So if I look at this first one that comes back, this build a natural Slack bot, and that's in Cypress, I can then find out that build a natural Slack bot is in that room because these are nodes in a graph, right? And so, but the thing that's different is that in this case, I'm only going to get the names, or I'm only going to get the IDs, or something like that. You can define this query side however you want, so you're not getting too much data. It's not like you're going to get all the session data twice. You may just get what you want. You may just get the ID along with that to say, okay, I've got this. I'm able to dig into this and figure out what I need to get from it. Okay. So how do you filter data? Well, GraphQL doesn't specify how you do filters and things like that. And so we're going to move to another implementation of a GraphQL interface. And again, you see graphical here. This is GitHub. GitHub has also implemented their API using GraphQL. And so what it comes down to it, all of these nodes are actually on the back end just functions. Functions that can be executed with parameters. So if I don't give it the parentheses and parameters, it just no parameters to that function and it executes. But I can then just give it anything I want. So in the GitHub interface, they basically say you can search for, issues, repositories, and users. That's how they've implemented it. So I'm going to search for repositories with GraphQL, and I'm going to get the first 100. So this is how you can do filtering. And then what you get back is the first 100. In here I just have the name and the description of the projects that are in GitHub. So that's how you do filters in general. And then you can abstract that in a way, like if you want to do like paging and things like that, you can abstract that in a way however you need to put paging. You can take paging parameters, like just take a paging parameter in every one of your things that could be paged, and then it could, I want the first 10 after a node ID, for example. You could add that to this query, and you could get that. So there's also this concept then of polymorphism within this API. And polymorphism meaning something that can be more than one type. In this case, the node can be a repository, or I'm just going to put this in line here. Oops. Sorry about that. Let's put it down here. Or it could be a user. That's not really working for me because it's not a valid query anymore. Anyways, let's pull this away, and we'll just look at the query that I want to talk about now. So I said type user. Now the thing is, in this particular implementation, the nodes that come back from the search could be users, or they could be they could actually be lots of different things. They could be repositories, things like that. And so what you can do then, let's say that there's some root data. You could say something like, I want the ID and the name from the node, which isn't actually a thing here. And then I can say, oh, and also if it's a user, I want this information on the user. Or if it's a repository, I want this information on the repository. And that's what the ... implementation is here, the syntax. And so I execute this now, and I'm going to get users now instead of repositories. Okay. So then there's variables. So if you think about this, all these queries that we're executing are, in practice, going to come from your client. They're going to be defined on your client and asking for data from the client. And so if I want to search for GraphQL, I don't want to do string concatenation for lots of reasons. I don't want to do string concatenation on my query. I want to parameterize my query instead, and I want to send variables. So when I define my query now, I can define variables that then get passed down into it. And so in this case, I can send an object along with that request for data to say that the query is GraphQL, and that gets passed into here, that gets passed into the search query as well, and now I can search for GraphQL with a parameterized query. If I did the same thing for, let's say, just node, I can execute that. I would get GitHub projects for node. So that's how you do variables in your query. So then I talked a little bit about, everything is either a query or a mutation, and we separate those things for a reason. And that is so it's very clear when you're changing data and when you're not changing data. So I know I'm calling this the section mutations, but the first thing I want to do is I want to query. So imagine you're a client and you're going to have a list of, you're going to query all of the repositories, and then you want to mutate something on that repository. You will have queried the data along with an ID, and you're going to have that ID on the client side, and then you want to make a mutation. So you're going to have that thing right there. So there's that ID. And in this case, it's a very simple repo that I created 8 years ago that I never did anything with whatsoever, but it still exists. And there are issues that go along with it. And so in this issue, that's what I just queried for. And so I said, give me for the user Brian Genisio, look at the repository my recipe box. I want the first 10 issues. There's one issue here, and that's the ID. So if I wanted to then mutate, make changes to that issue, I could add a comment, for example. So this is a part of the API, and I could just execute that. And notice I say the subject ID is that ID that came back. And then the body of what we're going to send is not scrolling. I'm going to say hello CodeMash. So I'm going to execute that. And now if I go over to my issue on GitHub, I should soon see, hopefully, maybe I reload. There it is, hello CodeMash. So that's how mutations work with this API. And then the mutation, so I add the comment and the ID and the body, and then I'm querying data back out of it. Because let's say you're going to create something new. You want to be able to get the ID of the new thing that comes back. And so you can then query anything you want. And this kind of keeps data fresh in a caching layer that may exist on the client. Okay. So we see what queries look like. How on a client do I get to it? And so it turns out it's really quite straightforward. I'm going to go into my inspector, and I've got this little snippet here. So really all you need to do is construct a document and post it to this endpoint, because that's how it's being hosted right now. Here's my query, sessions title abstract, and then I can fetch GraphQL as JSON. I'm going to post it, and then I'm going to stringify the query, and if I had variables, I'd stringify the variables as well. I get the result in JSON, and then I will see in the console the results. So I'm going to run that, and there's my console, there's my data, and there's my sessions. So at its very raw form, you see it's actually really quite straightforward to get at this data without any real library. It's just construct a document, post it to the endpoint, you get JSON back. Okay. You'll never really do this. This is meant to be illustrative. You know, just showing like there's no magic behind how this system works. But what you will likely do is use something called Apollo, or sorry, a client library called Apollo, or there's several of them out there depending on how heavyweight or lightweight you want it to be. We use Apollo because Apollo has a really nice ecosystem around writing client applications in JavaScript or in mobile applications. And so we have mobile applications that are using Apollo. We have JavaScript applications that are using Apollo. They're all kind of using it. And what Apollo gives you, which is really nice, is it gives you all the niceties that I was talking about earlier. For example, it caches. It maintains an entire cache of the data that it's asked for. So if you have two components asking for the same data, it's not going to ask for that data twice. Even if it's not the same query, if I say I want person ID, name, and address, and over here I just say I want person names, if it's already there, it's not going to make the request. It's smart enough to have parsed that data and know the types and know what's available to say, oh, I got that already. If you wanted to refetch, you can refetch, but by default, it's got this cache, which makes it really nice. I don't have to think about caching. Caching just works. And the same thing, if I have little sprinkles of queries throughout my application, because I've got a section about users and I have a section about content, and they're completely separate, and I don't want content querying user data and user data querying content. I have two separate queries. Apollo can say, oh, you're asking for two things in this cycle. I'm going to put this together and make one query, and then I'm going to split it back out and give you only the data you asked for. So it's a lot of really nice things that, that sit on top of this GraphQL interface once you start using it. And so I created this really straightforward React app to show how this works. This is the React bindings. But again, it's not just React. It's also, if we look at the client, you've got Angular and Vue and iOS and Android. There's lots of different links and implementations and bindings to this data. So let's look really quickly what that looks like. Here's the server. And so you know, it probably doesn't matter too much whether you know React, because this is mostly HTML here. But if you look at this particular example, it's really just a collection of rows, right? It's a table with rows in it, super straightforward. And so this is what a session row looks like. I get a session object, and then I've got this little helper here to get speakers from that and format it. I'm sorry? Font size, absolutely, thank you. Is that better? I can make it bigger. So this is the session row. This is each row. It's just a TR, right, with the data. And then here's the sessions. This is the entire page. Again, you're not seeing any GraphQL specific things in here. It's just, you know, here's my sessions, and I'm going to map my sessions to session rows. How that works doesn't really matter. What's really interesting to me is that, okay, now I can co-locate the data I want with the component that I want. And by doing so here, I have no transport level information whatsoever. I just have this co-located query that goes along with it that's been parsed once already using this tag and stored as a parsed query. And I don't have to deal with promises, and I don't have to deal with catching errors and things like that. I'm just going to get properties given to me, and it's just going to work. And it's because of this this little wrapper here. It's this GraphQL wrapper of taking the query and the component and getting a new higher order component out of that now knows how to talk to the backend. And then I just export that component. And so, you know, that seems really simple, but how does it talk to the back end? Well, that's actually pretty simple too. In the root here, we have something called an Apollo provider that takes a client, and the client just kind of defines where to get the data, and assuming it follows this query variables post-based HTTP interface, it just works. And you can adapt it to anything else if it doesn't conform to that specific API, but this is it. Now, whenever any component is wrapped and married to a query, it'll automatically get the properties when it's available. And it'll also get error data as properties. So you're not catching errors, you're just getting a property that says something is loading or something has errored. And so it's a really nice way to start writing your code where you are now saying, here's the data I want to show, and here's the data I want to retrieve. And again, you can have these queries sprinkled throughout your application, and you can ask Apollo to stitch them together and batch it in one query. And then when the data comes back, you will just get the properties you asked for. And if this has already been done, let's say you're navigating between UI elements, and you come back to this page in a single page application, Apollo says, oh, I got that data for you already. I'm going to give it to you immediately, as opposed to querying it because I've cached it. So there's a lot of niceties that come along with that. There are other clients. Apollo's not the only one. Relay.js is a React-specific state management / GraphQL mashup that Facebook created to use with React. Apollo, again, you can use it in a vanilla way. You don't have to have a framework. You can just use Apollo and you still get all the results. In fact, we have a lot of code, legacy code, that isn't React specific, that used to make fetch calls that we just replaced with query calls to our GraphQL interface, and then it just continues working the same way. In that case, it returns a promise, you get the data, and you move on. Loca is a very lightweight client library that helps along with the same type of things. All right. So that's client. That's the client side and the query side of GraphQL. Before I move on to servers and how servers work, any questions about that I can answer? Yeah. So Apollo maintains its own store. And so that is, in itself is state. Now, if I had a set of Redux reducers, well, at that point, if it's just data that has to go to the client and the Redux reducers don't care about anything, which turns out is 90% of the time, then we don't deal with it. Redux becomes our application state, not our data state. We kind of separate those two concepts of being, we get data from the server and we display that to the UI, but then we also maintain some sort of client state, which is like, which buttons have been clicked and maybe what tab you're on if you're not using URL parameters and things like that. That is what we use Redux for. I say 90%, it's more like 98% of the time, those two things are so separate that you can just co-locate your queries with your components. There are times, though, when you have like a Redux store that wants to give default values based on the data that comes back. Well, now the Redux store doesn't have that data because you put it in your client, in your view. Well, what you can actually do with that is you use something like Redux Thunks, and you can then use just the vanilla version of Apollo to make a request for the data you care about in that case. And because Apollo is smart enough to do caching, it doesn't make two requests. It'll just give your Redux store the data you care about. And so you can set defaults in your UI based on the data you've asked for and normalized in your Redux store, if that makes sense. So there is some duplication there, but you're kind of separating stores in a way and separating client state from data as state, if that makes sense. So, all right, servers. So a server is really nothing but a transform. Take a schema, a set of resolvers for that schema, and a document usually supplied by the client, and transform that into data. It's really all there is to it. How you get the data to it, there's implementations, there's tooling, there's all that stuff. It is available to you, but when it comes down to it, that's all it really is. And this is a hello world example. We've got a schema that has a query with a hello, which is just going to be a string. Okay, that's what a schema might look like on the back end. And a resolver is nothing but a function with the same name as the property in that schema that will resolve the data. And that can be a promise if it's going to be asynchronous. That could be just a string in this case. That can take parameters. It's nothing but a function. So you're kind of saying, I've got a schema. This is what the data looks like. I've got a resolver. This is how I get the data. And then I'm going to transform. I'm going to take a document, usually from the client, and I'm going to transform the schema and the document and the resolvers. I'm going to get a response, which is JSON. And so we'll look at that as, here's a very simple, here's a very simple server, just kind of brought together. Your schema, your resolvers, and your query, you're going to transform and get the data. And I will make this bigger. So I execute it, and there's my data that comes back. Okay. Again, like at its core level, that's all you're doing with everything. And when it comes to the turtles all the way down, your nodes all the way down, you can then have, if you have a property that's another node, you just return another object with more functions on it. And that's how it all works. And then, so let's say you want to wire it up to HTTP. Well, there's tooling already available. If you're going to use Express as a server, then you can use the Express GraphQL middleware. And you're going to say, use it, and this is the endpoint I want it to be on. Here's my schema and my root. Notice I'm not giving it a document, because now the document's going to come from the client. And then there's this really nice thing where I say, oh, and I want you to enable graphical so people can query this as a interface and dev with it. And we're going to list it on port 4000. And so that's that's how you would turn it into a server. So if we just look at it over HTTP, that's the full example. Here's our schema, resolvers, use it, turn GraphQL on. We're going to run it over HTTP. It's going to tell me to log into this server. I hit it up, GraphQL is up and running, gives me some examples. I'm going to just say query, hello, and there we go, hello world. So we're just trying to demystify what a server is. It gets way more complicated than this because software gets way more complicated, right? That's how we do things. But when it comes down to it, that's all it is. And when it comes to mutations, well, mutations are just a mutation part of the schema instead of a query part of the schema. It looks like a function with the data type. And then in the resolvers, you just have how to update. It's a function that takes parameters, and you can update. And so if you were to look then at what it looks like for a mutation, slightly more complicated example because now we're doing queries and mutations in the same thing. Here's my database. We've just got a property in memory. Hello world. The mutation is update message. Now I've got an update message function that takes the message. I'm going to set it. I'm going to return it. And then down here, I'm going to do the mutation document. I'm going to execute the mutation document. Then I'm going to execute the query. And when I do that, you will see that there's a mutated result. So that's all there is really to it. And then we just build on it. And so the CodeMash server, this one over here, is really nothing but a wrapper around the API. And so I have this thing called sources, which is really just, I've got the repo, which is they've got a, they basically have, there's a sessions repository and there's a speakers repository, and that's really all the API is. I cache it in memory for up to an hour just so I don't have, because it's kind of a slow REST API. This is running in Heroku. If anybody wants to play with it, I'll send you the link. But basically that's all I'm doing here. This is actually not GraphQL specific. This is just some code that will fetch the data and store it for an hour and refetch it after an hour. That's all that does. And then I can define my schema up here. Let's take a session. Here's my schema for the session. This is what it looks like. I have ID and rooms, which is an array of rooms, a title, which is a string, etc. And then my actual wrapper object, my interface object, is right here. That just is saying, I'm going to take a session, and most of these things are static, so I'm going to set them. But in the case of speakers, I'm going to make an asynchronous call, so I want that to be a function that returns a promise, things like that. These wrappers are really just wrappers. You don't put business logic in here. You are just adapting the data that's in your system to the interface. You delegate the business logic to the system that already exists. So you could have REST and GraphQL sitting right next to each other, delegating the same behavior. So we've been doing a lot in JavaScript here. At Khan Academy, our backend is written in Python. And so in Python, we use this tool called Graphene, which turns out is also available in JavaScript to use this. It just kind of makes the interface for creating nodes in your server a little bit easier. So we can look at how we do this in Khan Academy a little bit. We've got a rather large schema these days. And so we break it up. Our application is broken up into different feature silos. And so we basically have different GraphQL queries that sit on those different places. And we create them as what's called interfaces, basically. And we apply those interfaces to the meta level query. And so these are all coming from different places within our application. And so you can see we have articles, we have SAT information, coaches, which are teachers. You have users, things like that. Topics, these are just all the different education-based topics that we have. And then you delegate to the topics, and here's what a topic looks like. We define our schema essentially using properties here. And then this is your constructor in Python. All of our static things we just set right away. And then all of our things that are going to resolve asynchronously, they have this thing that says resolve underscore property name, and then you can get the parameters, return a promise, which is funny. We're in Python, right? But we're returning a promise because the Python implementation of the GraphQL server was based off of the Node implementation, which uses promises. So they implemented promises in Python because promises are nothing but an object that will return data eventually back to you with a callback. And so you have promises available to you now in Python, which is a little bit funny, but it is what it is. Okay. So let's say you don't want to implement a server. I don't want to get in that mess at all. Well, there are solutions for GraphQL database as a service out there, and the biggest one out there right now is called Graph.cool. It's just a GraphQL backend development framework. It's like parse.com, which is like becoming open source and died, and Firebase and things like that. But the idea here is that you can create your schema either using a UI or using strings over here. You can see your data. Let's look at, we're going to query people over here. And so here's my database. This is like just a document database with a whole bunch of like people in this case. And then I can go to the playground and I can query this. I can say I want to see all the people that are in my database, and there's my data and my query and things like that. And then your client can then just use GraphQL against this backend. And so this is a really nice way to just start playing with GraphQL with your data immediately, which is kind of neat. And then of course there's the in between. It's I want to implement a server, but I don't really feel like all the boilerplate of writing servers and dealing with Node and all that stuff. Well, there's a tool out there called create-graphql server. It's a lot like create-react server. It basically scaffolds an entire server for you. It defaults to MongoDB as the backend, but you can change that however you want. But it allows you to start building a server with some scaffolding and some help, which is really quite nice when especially if you're trying to learn and you're like, I don't know where to start here. So that's servers. Talk a little bit about tooling. So one of the things that we have available to us now is a Chrome plugin called Apollo Tools. Oops, sorry. And with these Apollo tools, we can see all the queries that went over the wire. I didn't name my query, so it's just calling it one right now, but I can see that my query now is, this is for this React example over here. I can see that I'm asking for the ID and the speakers and the first name and last name. And you'll notice that I didn't query for type name, but it's injecting that because it uses the type name in its cache on the client side to make sure that everything is efficient. It creates a normalized state based off of the data that comes back, and it needs the type name to get that. Because for any given node, there's a whole bunch of underscore metadata that you can get about it and type information, which is how when if I go say run this in graphical, that's how these documents are generated. It does a query off to the GraphQL service to ask for the metadata for the schema. So all that metadata is also queryable. There's no special interface to it. It's just data that's queryable to you. Apollo Optics, this is a thing that sits between your client and your server that will give you all sorts of error and analytics information about the health of your GraphQL server. ESLint has a plugin, and honestly, this is one of my favorite things about it, and I mentioned it before. But if I have an invalid query in my code, what ESLint does is it looks for anything with a GQL tag on it, and will then compare it against the schema, which you can get many ways. One of them is fetch GraphQL schema. You can get the schema, and you can compare them and say, oh, this is a problem. And so, like, we don't allow check-ins if our code doesn't lint, and so I can't check in code that will break against the server, which is really quite nice. And if I did manage to like do a bad merge that did check in code that broke against the server, my deployment server will catch it when it does all of its tests, including linting. So it's a really, really nice check to make sure that I didn't accidentally break something. And then we use React Native for a lot of our native work, and so the same queries are happening over there, because it's very common that I'll write my web app and I'm like, oh, I'm cool, everything's great. And then I actually broke my mobile app because it's a different project. And so then we'll get, before they deploy any broken changes, they'll be like, hey, you just broke us, or we're going to fix, what you just broke. There are a lot of, best practices here that I could go over, but because of time, I'm just going to talk about a few things. These are just general, like, how to think about things that, if you're used to doing REST interfaces, you may be doing differently in GraphQL. For example, like in a REST interface, if I'm going to query a person and get the parents of that person, I'll usually just get IDs. That's usually how we're going to implement it. We're not going to give all the parent data. You can ask for that in a separate REST request. And so the person who may have a lot of experience in REST would come to GraphQL and might say, okay, I'm going to give parent IDs. But we want to think in graphs now. We don't want to think in resources and multiple requests. We want to be able to say, I'm going to dig into the person's parents, and if I want the ID, that's what I'll get, but then I can get more information as well. And so instead of returning IDs, return parents as nodes, and then they can query for the IDs themselves. Here's another one, which is avoid redundancies. Don't have a list of parent names when you can give a list of parents in which you can query the names. Again, this makes the API a lot more flexible to the person asking for the data, and chances are that it's going to be the same amount of database requests to do it either way, but the one below is better. And now you don't have redundancies if you just have the one. So avoid redundancies. The difference is, something that you may find yourself doing is aggregate data. Like if you wanted parent count, for example, you could do that by saying, I just want parent IDs and then count on the client. But now you're doing a lot of extra wrapping. You may add aggregates to your API and have parent count as a node that you can get, and because the database could be much more efficient in getting just that. This is the case with this is also the case with REST interfaces, and in many cases. But be really consistent with your singular and plurals. One of the reasons is because if I ask for a person and it's singular, I'm going to get an object back in the data from the data JSON. If I ask for something and it's an array, like a plural, I'm going to get an array back with these objects. And so there's no specification in this query language, which I wish there was, that would identify that this is an array and this is an object. But by keeping consistent with your pluralities, it becomes pretty easy to read it and understand what is coming back. The next one is abstract your business logic. Those resolvers, those data resolvers should do really only three things only. Should take the parameters that come in and adapt them to your business logic parameters. Number two, it should call your business logic. Number three, it should take the result of your business logic and adapt it back to the outputs of the interface. Because this is the case for REST too, in my opinion, or any RPC call. These top-level things are nothing but interfaces to a larger system. And that allows REST and GraphQL or any other RPC to exist in the same space. And then you kind of delegate authorization and authentication and business logic and all that stuff to a different layer. You don't let the GraphQL interface deal with it, because it doesn't. It doesn't deal with authentication. You deal with authentication, and you deal with transport level cookies, or however you're dealing with the truth of who you are, and you deal with authorization, so to make sure that people don't go in and query user data on different users, things like that. And by abstracting it this way, you make sure that that is the case. All right. So I want to spend a little bit of time talking about what are the problems with GraphQL. And the first one that I'll talk about is like infinite nesting. So let's take a scenario where you have a comment feed. And that comments can have replies, and replies can have replies infinitely all the way down. If I had a REST interface and I asked for all the comments, I could get that, and eventually that tree would terminate because it's not cyclical. It's actually a tree. But GraphQL is a graph, and so GraphQL doesn't really know the difference. So if I did that, I don't have a really good way of saying, give me all that data in an infinite nesting way. And so you might start writing a query that looks like this. I want my comments, and I want the author and the text, and I want the replies. And from the replies, it's really probably the same node. And I want the author and text, and I want the replies, and I want the author and text, and I want the replies, until you're done. Now, if you did this 6 levels deep, there might be 7 levels of comments, and that's not great. And so we do have this concept of fragments, at least. And so you can say there's this fragment called comment fields called author and text, and I could say comment. I could then query the comments and say I'm going to get the comment fields and the replies. And then you may find yourself saying, well, why can't I just take replies and put that up in the fragment and then have the fragment refer to itself again, right? And then I could write a query that looks like this. Comments, give me the comment fields. The comment fields have author, text, and replies, and inside of that, take the comment fields, right? But because we're thinking in graphs, that is now circular reference, and that could go forever. And GraphQL doesn't have any real way of knowing the difference between those two things. And so it turns out that this, having cyclical references within your query when it comes to these fragments, is explicitly disallowed in the querying. So this to me is a negative. Like if you have something that has that type of data or is going to rely on that heavily within your application, GraphQL may not be a good solution for you. If it's just like you have comments in one place, well, maybe you can create a UI that will just get the next level deep of comments if you open it up. There are ways to mitigate it. There are ways to mitigate all these negative things that I'm going to talk about, but it's, to me, like that can be a pain, and it's something that will trip you up. And if you have data like that, it's something you can know about ahead of time. The other thing is it's extremely possible for me to write a query that will take down my server. So, for example, let's go rooms. I think. Why isn't this working? I don't know why this isn't working right now, but I'm not going to deal with it. So let's say I've said rooms, sessions, rooms, sessions. And I did that like 100 times. You're actually kind of exploding it out and exploding it out and exploding it out. If you think about the tree that's going to come out of that, you're going to be actually like creating giant structures. And you can run out of memory just by creating the stringified data or the tree or whatever. And so it's possible then for hackers to create denial of service attacks if you don't protect against it. It's also possible for client developers to accidentally create queries that are really expensive. And so it's possible and often the case as you're developing a server that you can implement things in an expensive way. And so my recommendation for that is that all queries have names. We actually have a lint rule that says all queries have names. And then we log on the back end the time it takes to do all queries. And then we can see what the expensive queries are. And then we can go, look, can we make the query faster? Can we cache data in the session on the back end as we're figuring things out? What can we do there? Or does the client need to rethink how they're doing it? Now, it doesn't happen that often, but when you have hundreds of queries, some of them are going to be more expensive than others. As far as denial of service attacks, you can make it so so these queries are whitelisted. So there's tooling that can go through your client, for example, and if you don't want to make the API public and completely navigatable by the public, you can go through and find all the GraphQL query tags like we do with ESLint, create a list of whitelisted queries, send that to the back end, and then you can stop any other queries that happen. And then next time you build, you just get a new set of whitelisted queries. So there are solutions to this, but out of the box, it's a problem as far as I'm concerned. So N+1, the N+1 problem is a pretty common problem within software. Let's say you have an object that has a relationship to many other objects. You have a person who has many children. In an object relational mapping world, it's in a naive approach, you can actually have one database request for the person and one database request for each individual item. That's called the N+1 problem. It's a common architectural problem. Well, a naive approach to a server could do the same thing, because I could just say, okay, I'm going to go get this item, get this item, get this item. There are patterns to make it better. There's a pattern called the data loader pattern, which is used, basically what happens then is it kind of queries up all the things that you want, and then in a batch, allows you to batch your queries. So I can do it in 2 queries, for example. I can get the user, and then I can get all the parents in another query. There are solutions to it, but you have to architect these solutions, because again, GraphQL is nothing but an interface layer. It doesn't solve architectural problems for you. It's also possible to overfetch from the database. Here's a query, for example, students, assignments, ID, that you could find yourself querying all the data for the assignments when you didn't need to, because the representation on the back end here is I may, let's say, take it out of a document database or something like that, and I have nothing but assignment IDs. I already have the ID. But when I go and then have turtles all the way down with my functions, and I ask for the assignment of the students, I'm going to say, oh, I need to go get the assignments for this ID. Oh, and here's the ID, right? Again, there are solutions. You have to architect them, but in the naive approach, you can run into overfetching data from the database accidentally with data you already have. And then yet another API, really, like SOAP. Isn't this just SOAP? Right? Like, if you've ever used SOAP, it's like a typed API, and we're doing it over JSON, but like in many ways, like this is we've seen this before, right? And SOAP had problems. I think they've probably done a better job than SOAP did, because we've learned from mistakes of the past and made things better. But there are all these formats that have come out, OData and Falcor, which are actually doing similar things as GraphQL. Do you really need another API? Well, it depends on your ecosystem. It depends on your team. So that's it. That is like the world of GraphQL in a nutshell. Client server queries, everything like that, the goods, the bads. Any questions that I can answer?